Let's do a simple question of DC circuits, simple DC circuits, where you have 4 resistors, 20 ohm, 30 ohm, 10 ohm, and 40 ohm, and over here there's a battery of 100 volt. This point has been earthed. We have to find the absolute potential of D. We have to find the absolute potential of D, right? So as we know, that is, if a body is earth, conductor is earth, or you say point is earth, what does it mean? Does it mean that the charge, conventional current, goes over here, gets into the earth? Does it mean that? Many of the students, they feel like this, that is, earthing means that the whole current goes into the earth. So that may or may not be the case. Remember that whenever a body is earth, conductor is earth, the mandatory thing is that it has an absolute potential of 0. That is mandatory. And then it depends from question to question, that is whether the whole current will get into the earth or not. Like over here, this is a battery. What the current goes this way, the same current it has to enter this way. We are talking the conventional current. What the conventional current goes out, the same current immediately it has to get in. But it doesn't give the charges on the credit system. That is, now today I am giving the charges, return me the charges later on. No way. It wants the charges immediately back. So if some current goes over here, and you say some current gets into this, so it means finally there will be less current getting back to the battery, and this is not possible. Over here, this has been earthed, B has been earthed. It means the absolute potential of point B, that is VB, is equal to 0. Absolute potential. You know, there's a difference between when you talk about the absolute potential and when you talk about potential difference. There are two things. A body has been earthed, it means the potential, absolute potential of this is equal to 0. Now, we have to find the potential of B. Let's see how we do it. The current goes from here to here also, here to here also. There will no current which will get into earth, right? So, the potential difference across A and C, these 2 points, you take any path, you take this path, you take this path, or you take this path, that is 100 volts. So it means the potential difference across A and C, that is also 100 volts. If I take A, B, C, I use V is equal to IR, Ohm's law. V stands for potential difference. Potential difference across AC, that is 100 volt. I don't know, I call it as I1. Suppose I call this as I1. R is what? 20 and 30, they are in series. So 20 and 30, 50. So I1 comes out to be 2 ampere. Similarly, if I take this, that is ABC, path ADC, arm ADC if I take, then across A and C, the potential difference is once again 100 volts. So 100 is equal to, suppose I call this as I2 into once again 40 plus 10, 50. So I2 is 2 ampere. Once again, please don't get into this. You find equivalent resistance 20 plus 10, 30, sorry, 20 and 30, 50, 50 and 50. They are in parallel, so that makes equivalent resistance as 25 ohms, 100 divided by 25, 4 ampere goes over here, 2 ampere, 2 ampere. Please don't get into it. It is not any time you see the combination of resistors and you get to solve it using series and parallel methods. So using this, I find 2 ampere is over here, and the value of I2, that also comes out to 2 ampere. You can use KCL. If someone asks what is the current in this, so what's the current is this, that is equal to this plus this, so this has to be equal to 4 ampere current. Though it is not required here, in this question it is not required. Current goes from A to B, that is a conventional current. Conventional current goes from a higher electric potential to lower electric potential. It means the potential of this is more as compared to the potential of this. The potential difference between these, point A and B, is V is equal to IR, 22, 40 volt. So this is at a higher potential as compared to this. and the potential difference is 40 volt. This is at 0 volt. So this is 0 plus 40. That is, this point, A point, is VA is equal to plus 40 volt. What is it? Plus 40 volt? It is an absolute potential. Potential difference between the 2 points is 40 volt. This is at 0 volt. This is 40 volt above this. Why? Because conventional current is going in this direction. Conventional current goes from a higher potential electric potential to lower electric potential. So potential of this is 40 volt. And over here, if I say potential difference across this, 2 into 40, 80 volt. 80 volt is a potential difference. This being at a lower potential as compared to this, because conventional current is going in this direction. So this is 80 volt lower than this. So potential of this is this potential minus this potential. So potential of D is equal to 40 minus 80 is equal to minus 40 volt. So absolute potential of D is minus 40 volt. This you can also go from here to here also, you can also go from here to here. You can take any path of your choice. Across this, you say V is equal to IR. Current in this arm is 2 ampere. So 2 into 30, this is 60 volt. This is at 0 volt. This point is 60 volt. Below this, 0 minus 60. So VC is equal to 0 minus 60 is equal to minus 60 volt absolute potential. This is absolute potential. Now, current has been going from here to here, and the potential difference across this is 10 into 20 volt. Potential difference is 20 volt. Conventional current is going from here to here. So this point is 20 volt above this point. This is at minus 60. So minus 60 plus 20. Once again, it makes minus 40 volt. So any path you take and you can get down.